Hello, I'm Park Chun Guan, and I would like to share with you the affordances of an ICT tool called Virtual and Augmented Reality and how it can be used for teaching and learning. Gibson defines affordances as properties of the object that are inherently there regardless of whether the user knows it or not. However, Norman defines perceived affordances as more important and that will affect how it is being used. Affordances can be classified into three areas: pedagogical, social, as well as technical. What is VR and AR? VR is really an immersive media experience that replicates a real or imagined environment, while AR is actually a sort of an augmentation or enhancement of the real environment. Let's watch a video right now. In the video, you can see that students gain fresh perspectives by going into the virtual cell and coming face to face with certain cell organelles and then understanding and being curious about its function. We've also seen how students are placed in the virtual lab environment to manipulate enzyme and substrate molecules, and this will help them to understand the molecular interactions between substrate and enzymes in the lock and key hypothesis. Affordances of VR in education can be summarized through this framework, whereby VR can help students to construct learning and avoid 2D imagination-caused spatial misunderstanding that is often present when students look at just textbooks. There are three characteristics of VR, which is immersion, interactivity, and information intensity. These are the key affordances of VR, and it can be seen, for example, when a climber climbs a virtual mountain in the Climb software. I will now show you and explain to you how immersion and interactivity work together in a virtual lab enzyme software. Basically, I'm setting the variables right now and I'm controlling how much of the enzyme and substrate concentration will go into the experiment. And I'm actually enabling and confirming the reaction settings right now. And what I'm doing is I'm actually going into the molecular level interactions to see the interactions. Notice that in VR, the cues are all visual. In order for me to hold the enzyme molecule, I will just have to look and ensure that the red dot is fixed on the enzyme. And as I hold the enzyme molecule, I can manipulate it, I can turn it around anywhere that I can, and I can see how does the active site really look like in the enzyme molecule. I can also change the pH, of which in this case, you can see that the enzyme molecule has expanded, or what we call denatured, and the active site is no longer, is changed and altered, and no longer able to accept a substrate molecule. So the power and affordance of the VR software is that the student can actually see face to face with how the enzyme and substrate molecule look like, and if he or she tries to change the pH back to neutral, what happens? In this case, the enzyme remains denatured. Enzyme VR really adds a sense of realism to help students understand why enzymes cannot work in extreme pH or alkaline conditions. So this leads us to the next question of the design of affordances in VR and AR software. That Gaver emphasizes the importance of making affordances perceptible through metaphors and intuitive controls. I will now show you the affordances in another software, the virtual cell software, and explain to you how the design of affordances can aid students in their understanding. You can see, by lifting up my left hand, I can immediately see a menu whereby I'm able to assess and decide which part of the cell that I don't understand, be it the cell membrane, be it the Golgi body or mitochondria, that I like to find out more by looking at the structure. So right now, the student is assessing and seeing the cell membrane in 3D, and he or she is really moving the structure around to see the different components such as proteins, carbohydrates that are present in the cell membrane, and this will help them to understand better how the cell membrane works. Student remembers that the teacher has taught them about endoplasmic reticulum and decides to assess the menu to see more about this structure. So as a student brings up this structure, he or she can see that there are many folds. He can also see that there are structures like ribosome, and the students can then wonder what and how do these molecules work together to enable them to work as protein processing sites. So in the virtual cells software, the perceived affordances of autonomy aids in promoting engagement and ownership of learning. I will now elaborate how a lesson can be designed that taps the affordances of VR and AR in a science lesson. The lesson begins by letting students experience augmented reality as they put on red sunglasses to see these 3D poses of the virus. Engaging the students will set the lesson context because students will then understand the difference between viruses and cells and why the SARS coronavirus is so deadly. During the exploration stage of the lesson, students also have the option of viewing 3D videos. For example, in this case, you can see a 3D video of mitochondria, and students who are interested in this particular cell organelle can find out more. They have to put on the 3D polarizing glasses, and this is basically augmented reality. So you see that students are able to have the autonomy to interest and to see where they want to find out more about which part of the cell. During the explore stage, students will get to experience the VR software. For example, they will go into the virtual cell software and learn about the cell organelles and why is it different from a virus. As we know, formative assessment is an important aspect of every lesson. We need to know how students learn, and that is how students will then show what they have learned about viruses and cells through the AR and VR software. In the lesson design of VR/AR based upon the affordances, it is very important to consider and hear the students' feedback and then improve the VR software or even the pedagogy of conducting the VR and AR lesson. I will now touch briefly on the development of technical affordances, particularly with respect to the hardware, because really there are many factors that will affect the usability of VR software. For example, my school has opted to use the Oculus VR as it offers a high quality immersive experience. In addition, Oculus VR offers very good intuitive controls, and the user can play for long periods of time without feeling nausea. To summarize, a key affordance of VR is that it allows multi-sensory interaction, and this allows users to construct meaning from experience. So this is very important in constructivist learning, whereby when we teach complex and abstract ideas, students can then be able to better understand and be able to formulate their own hypotheses. Research by Gargano and Lee shows that there are various affordances of VR and AR, and this has to be taken into consideration when the user designs learning tasks.